Welcome back. I had some hard drive problems, but this project survived. At least I think it did. So today we're going to address some flaws in our interface just to try and cement it down so it feels good. When you're building a game, making it feel nice right at the beginning is definitely the best option. Because then you really then it feels fun to play when you're playing it. But we also would like to fix that bug where we landed on the edge and it didn't actually trigger. So that only happens with these diamond shaped or these L-shaped blocks. But you see what I'm doing? It happens when this brick catches and that brick doesn't catch, but it only happens some of the time. And I'm not sure what's going on there, and I'm not absolutely sure that we'll be able to fix it. So let's go ahead and work on the really overreactive button pushing. See how it's going in 2 steps? I want it to go in 1 step. And really the key here is that when I am pressing, I'll show you. When I press left, this fires in block controller. And this says, oh, okay, so you're pressing left. That means that horizontal equals -1 or somewhere near -1. So our current x is, well, it's our current x position, but we're going to go ahead and round it. And this is the problem, because down here we say target x equals current x minus 1 or target x equals current x plus 1. But if we've rounded it, then if it was 1.4, it's now equal to 1. So if I'm pressing left and I'm at 2, let's say we're at x position equals 2, and I press left, I slide and I'm at 1.9, 1.8, 1.7, 1.6, 1.5, and then all of a sudden my current x goes from being 2 to being 1 because I'm rounding down, which means that if I'm holding left, I only have to hold left for a tiny amount of time before it moves me another space to the left. And the answer to that is not to change how this works, because this works correctly. The answer is actually here. If the horizontal equals 0, then we want target x equals current x. Of course, we do have to move current x up above. And so what this means is that if we stop pressing left, we'll stop moving left, well, to the nearest integer value. And that'll really prevent that slidey feeling. So, see? Much snappier. And if I want it to move 2 spaces, I hold it a little bit longer, and it moves 2 spaces. But if I only want it to move 1 space, I don't hold it very long, and it works fine. It's still a little bit slidey, which is something we might be able to fix later. So there's that bug again. And what we're going to do is we are going to add in a gizmo. Everyone loves gizmos, right? I hope you remember what a gizmo is. We added them a couple scenes back, and you can't see any of them very clearly here because YouTube is a little bit shy on the pixels per inch. Resolution, yeah. There is a tiny blue dot in the center of all these parked bricks, and the reason for that is because over here in chunk element, each of those bricks is a chunk, as you might recall. We actually do on draw gizmos, and we draw a line to where we are trying to be. But unless we've been bumped, we are at where we are trying to be, and it works fine. So we don't need to worry about, this gizmo doesn't actually draw here. But up here we say if flying solo, then return. What we actually want to do is we want to draw 2 different gizmos. We draw one gizmo if we're flying. We draw one gizmo if we're part of a larger brick, and we draw another gizmo if we're not. Now the great part about on-draw gizmos is gizmos only draw when you're looking at the scene view. So we can actually clutter this up. We can put in some expensive stuff here in terms of computation, and we don't have to worry about it slowing down the game at all, because it's only going to do anything when we're on scene view, which is handy. We might as well just make this color global. We don't need any other colors. So here we're going to go ahead and draw a can slide in direction line. So we're going to go ahead and say bool can slide down equals can slide in direction, and then we'll just use the vector 3.down. And what we're going to do is, if we can, we will draw the gizmos so that there's a line moving down. So if can slide down, draw the gizmos. If we can't slide down, let's go ahead and just change the color and also draw a different kind of gizmo. See how we've got all sorts of options here. Let's go ahead and just draw a cube. Well, no, we are a cube, so that might be a little hard to see. Let's go ahead and draw a wire sphere. And we'll center it on ourselves. Actually, let's go ahead and center it at our bottom so that we'll really see that it's the bottom we're actually checking for. The same, we'll do the same up here. This way we can later add in gizmos that detect left, right as well without, and we'll be able to keep track of what is what because they won't be coming from the center of the brick, they'll be coming from the edge. And the radius, let's go ahead and make it 0.5f. So now, if we hit play over here, and we go into scene view and we watch it happen, make sure that we didn't have, yep, see, you can see the blue lines and you can see how they turned red. That's exactly what we want. So, let's go ahead and play through this one frame at a time here. I believe this actually is a physics frame rather than a, well, whatever. Alright, you see how it currently says you can't slide down? So that'll be a big help in debugging why our L shapes, or not our L shapes, our S shapes don't work. Come on, this is the piece I don't want for once in my life. Here we are. Alright, so let's go ahead and pause. Take a look. And so you can see what we've got here is we can't move down here and we can't move down here, but we can move down over here. So the question is, why isn't this settled? This should have turned into, this block should have gone away and these should be individual chunks. But for some reason, it's saying that it's still not ready to settle. And there are a couple of reasons why that could be, because there are a couple of things that we're actually doing here. If we look over here in the block controller, when we do our on-collision math, this is where we actually do our work. We round ourselves to an actual local position because we don't want to accidentally settle on something that's not an integer value. And it could be that in the process of rounding there's something screwy going on and we're not ending up at the proper position. So what we're going to do is we are going to steal this, and for now we'll just stick it down here, and we'll go back into chunk elements and we will add a gizmo to our block controller. And we will calculate out the position that the block controller thinks it is at logically, and we will draw a yellow circle at that position. Alright, so that should compile, and will it run or do I have to restart? I think I might have to restart. Darn. Alright, so we'll just hit play again. So if we look at the scene view, we're going to have to pause it because that went by way too fast. Pause. Alright, so you can see that yellow is actually really hard to see because the Tetris block itself is green, and so you've got a yellow and a green, and that's very difficult to see. So let's go ahead and change the color to black just so we can really see it. And you can see how it snaps down. So that's the logical position that it thinks it is at all times. And that's going to be very handy when it comes to trying to debug where the brick thinks it is when it fails to actually settle. Stop giving me I-beams. I knew I should have left you out. What the hell? Is our randomizer broken? Well, that's not an I-beam. We can't rotate these things yet, so I can't do the experiment with that shape. Or this shape. I really do need an S-beam. Come on, you monsters. Oh, we have the same bug with a different block. Okay. So here you can see that in this case, oh, this is really interesting. All of these bricks can't slide down, and it thinks it's in the spot that it actually is. So why hasn't the control gone away? What has happened that means that this brick is still in existence and still under our command even though each of the individual pieces is saying that it's not ready to fall. And I think that the problem might actually be that logical position. I think it might be that problem after all. And the reason I think that might be the problem is because that circle is not where I expect it to be. It's 0.1 meters higher up. And we can show that by drawing a second wire sphere. Like so. But we're going to want to change the color because, or we can change the size. Let's go ahead and change the size. Alright. So now if we hit play again and go to the scene view and zoom out, pause. Now you can see there are two, and you can see how that bigger sphere is our actual center, and our logical position is actually up here. And that means that the problem might very well be that our logical position is not where it should be. And here's the problem. We are rounding our position.y, and we should be flooring it. For x, rounding works, but for y, we're always going to be moving downwards, so we want to floor this position. So, there we go. So that is where it is planning to stop. And if we were to advance, you can see how we catch up with it, and then it comes down and it says, okay, we're definitely settling there. And it settles. See? So let's go back into our game, and I think that probably fixed our bug. But let's go ahead and try and cause it again and see what happens. No. Poop. There's definitely the same bug. What's going on? What are you doing? Oh, look at that. So in this case, our position is something like, well, 0.98. You see that? There's the other half of the bug. I certainly didn't mean to turn that into a 3. I'm not actually sure how that happened. Because we're physics objects that are affected by gravity, we're squishing into the ground a little bit. So while we need to floor our position, we also need to be a little bit generous with where we are so that we don't end up flooring ourselves through the floor. So now let's go ahead and try this again. Alright, so that worked. Give me an S block. It's been 10 minutes since I've seen an S block. I can't imagine that I accidentally deleted them or something. That would be quite strange. What the hell? Ah, huzzah, an S block. Alright, so let's go ahead and take a look at it in scene view. And here you can see the actual position is the large sphere, and the small sphere is the position it plans to settle at the moment. So it's like, well, can I settle there? Well, it looks like I can still fall. Look at all these blocks say they can still fall, so I'm not ready to settle yet. Okay. Now this block over here says that it's going to collide with something. Alright, so now I think I'm going to settle there. So one of the issues here is that these blocks, these lines here, are actually done from the position of the blocks as they are now, rather than the logical position here. So what we could do is we could add another gizmo which would make these blue raycast lines from the position that the block is trying to reach, rather than from the position the block actually is. But I think it's good enough for now. Alright, so we did not fix the bug. Although all of the blocks turned red, it didn't settle at all. The only reason I can think of that is that it might very well be that our logical position needs to be fixed up. So let's go ahead and steal this. Now, optimally, we would put this in some kind of function that could be called, rather than keeping and copying and pasting. So let's go ahead and do that. Public static vector3. Oh, let's go ahead and let's not make it static. Let's go ahead and make it. Well, I guess we could make it static. It wouldn't work. It wouldn't matter. Yeah, it's fine if it's static. Logical position. Vector3 current position. This position right here. There we go. So here we just say equals logical position transform.position. And this is because we were copying and pasting so much code, and it was definitely not a good idea. You never want to have, even 2 is pushing it, but you certainly never want to have the same stuff in 3 places, unless it's for some reason you can't set something like this up. So over here in chunk element, we're just going to change our gizmo here, so that instead of just doing can slide in direction from where we are at the moment, we're going to do can slide in direction from block controller dot logical position transform dot position. And that will actually broadcast from where the brick is. The only problem is that the logical position actually uses this rigid body dot velocity. So even though I programmed it to be static, it can't be static. I wish it could be. So we are going to have to just do it like this. And this will inherit whatever position you send to it. It doesn't give you the logical position of the parent. It gives you the logical position of whatever position you pass to it. But we have to know what the parent is so that we can add our rigid body velocity. And therefore, we can't simply do this. We actually have to do get a specific block controller, and that would be transform.parent.get component block controller dot logical position. Now, this is a little bit of a C-sharp trickery if you're not familiar with it. So this will always return a block controller. We don't have to try and find something named block controller. We just pass it the actual script. We actually pass it the class, and it says, oh, you're looking for that particular class. Okay. And that's much better than having to pass it a string named block controller, but it didn't work very well. What's screwed up? What are you talking about? An object reference. I know there's an object reference required. That's why this has an object reference. It's not. That was weird. It must not have caught up with the fact that I changed it out of being static. Alright, so if we take a look, you can see that these are... Oh, we're actually drawing the line awkward. We're drawing the line from our transform position. See how that is? So we're actually going to draw it from... no, that's the block controller chunk element. Here it is. So here we see transform position, vector 3 dot down. So what we're going to go ahead and do is we are going to make this vector 3 logical position equals, and we're going to go ahead and put that here. And that's just so that we can replace all of these with the logical position so that we can see what's actually going on. Because while logically what we were doing was working fine, it wasn't visibly working fine. We couldn't actually see the lines. So let's go ahead and try that again. Although we just saw it worked, but we'll go ahead and do it one more time here. I'll wait until it gets a little bit closer to the ground and then pause. And we look at this in the scene view, and you can see how these blue lines are now below the bricks, and that's because they're working from the logical position rather than the actual position. And you can see that they've collided with the ground, and in turn, the brick settles just fine. So now let's go ahead and see whether or not we can get this to have an error. So you can see that that all works, and then the logical position will jump now, and you can see that there's a collision. And it went away. Okay, good. So I couldn't replicate the bug with that drop. I'm not sure if the bug can be replicated at this point. So that was fine. Well, it might have been an error. I don't know. I don't think it was. It felt fine. By the way, the little pop back is due to the way that I fixed the overslide earlier today, earlier in this episode. So if you don't like that pop back, then you can change how that works without too much difficulty. Sorry, I just got a case of the hiccups. I'm not seeing any catch bugs. I'm not seeing any slide bugs like we had before. So let's go ahead. This is the most likely piece to have that bug. And you can see it's the exact same setup as it was before. And we'll just paste forward here and bump. Ah, so there's the bug. And I'm not sure what's causing this bug. So what we know for sure right now is that it has definitely got a red ball here at the logical position. So it definitely knows that it's supposed to stop, but it didn't stop. Now that might be because the collision is wonky. For example, it might be that it collided here between these two rather than here between these two. And that seems to be the most likely thing that could happen. So what we're actually going to do is over here in Block Controller, when we are in the collision, you see how I just say context 0 normal y? The whole problem that we're having, I believe, is that there are 2 points of contact. And therefore, what we should do is we should walk through both points of contact, or however many points of contact there are, rather than assuming that there's only going to be one. So what we've just done is we've said that look through all of the collisions. If any of them have a y-coordinate, a significant y-coordinate, then we are fine. If none of them have a significant y-coordinate, then stop. Don't go through this collision enter thing. This is only intended for when you're falling onto something. And I think that that's the change we need to make. Although it won't work until we hit play again, so let's go ahead and try it one more time. However, there is one thing that might bite us in the butt here. On collision enter, I'm not sure whether it gets called when a number of colliders, when you're impacting the same collider in a new way. I'm not sure if that's the case. So let's go ahead and take a look here. So that's red. So you can see how we collided. We've got this colliding, we've got a collision running right now. And hopefully it didn't work. We may have to add more complicated behavior to the collider, but this episode's gone on a long time, so we're going to stop here for now.